test. Yeah. So hi everyone. I'm Elizaveta, and I work as a data scientist at Bolt. Uh, Today my talk will be less technical than previous one. I came here from Tallinn. I work and live in Estonia. So my background is in econometrics, statistics, quantitative methods, and today we'll talk about experiments in data science. But first, a couple of words about the company where I work. Both, it's like a Uber or Yandex Taxi, but much better and cooler. Why? Because it's the fastest growing ride-hailing company in the world. Here we can see how fast we have grown during past years. And now we have 25 million users in 30 countries. We operate across the whole globe. Our main markets are in Europe and Africa. And just recently, 2 weeks ago, we launched in St. Petersburg. And we are planning to expand more in Russia, so soon we will try both here as well. Today, my topic is experiments in data science, and why I will talk about it. Because it's a crucial part of product development, of growing and scaling business, as we learned from our own experience. You work in a company, and your company has some product. From time to time, you introduce new features, but doing this, you want to be sure that your features and your changes will be beneficial for a company, that they will grow number of sales, number of orders, improve customer experience, increase engagement and user retention. And it's what experiments in data science are made for. So, but knowing not only what are experiments, but knowing how to do it in the right way, knowing what are potential pitfalls in experiments, it's what makes difference between good product and great product. And here we want to, in our company, make great product. So today, in my presentation, I will share with you how you can do experiments, how you can avoid common mistakes, and how you can results which you can trust. I will start with a traditional type of experiments like A/B testing. Then I continue with multi-armed bandit-based experiments. And also I will share with you what are tests without control group. In the end, I will summarize with tips and tricks. And let's start. And first, a couple of questions for you. Who of you know what are A/B testing? Okay, great. And who of you have ever done any A/B tests? Okay, a couple of arms here, great. For all of us to be on the same page, A/B testing, it's a control randomized experiment with at least 2 groups, control and treatment. And the goal of this process is to measure and quantify impact of considered variable. This A/B testing can be like A/B-N testing when you have more than one treatment group. It can be used for new product features, for some changes in your product, but also for machine learning models. When you train better model with higher performance, and you want to test in real life, is it actually better or not? Let's at the first glance, it's really easy, but in reality, it's not. And let's consider a simple example. We have our app, where in Bolt app, where you can make an order for a car. That car will arrive to you, and you will go to your destination point. And we have this button, select Bolt, which means that you want to order a car for you. Let's imagine that once we decided to change the color of this button because we think that red color will increase number of rides. We are, as a data-driven company, we don't want to roll out just this new color for everybody. We want to test it first. So we launch a test for new user interface, for new color, and our goal is to increase number of rides. We split all our users in 80-20, and 80 will be our control group, which will see old green color for a button, and 20% of users will be our treatment, so they will see new red button in their app. We run this experiment for some period of time, let's say for a week, and afterwards we measure what was the average number of rides in both groups, in control and treatment, and we plot this beautiful chart. We observe that treatment group has a higher average number of orders. Question for you again. Who of you think that we should roll out new color for everybody? Our treatment group has higher number of orders, so it's better. Some Somebody thinks that we should do it? No, because actually it's something fishy here. And as you could remember from your undergraduate statistics course, mean or average doesn't tell the whole story about your data. And you also should look at such metrics as standard deviation, variance, and confidence intervals. And let's look what we have. I don't, if it's visible, there are confidence intervals here as well. And we see that confidence intervals for control treatment group overlap with each other. And statistics tell us that if these confidence intervals between groups overlap or cross each other, there are no statistically significant difference between control and treatment group. So just adding some additional information, we see that if we would stop on this stage, we would make wrong conclusion. And adding some additional metrics, we actually see real results. But it's not only thing which could go wrong. What else? Wrong metric. We, in our this imaginary example, we will look at number of writes. We compare control and treatment group with this metric. But maybe we should look at conversion. What was conversion of users from making search to making order? Or maybe it should be average times which users spend between search and order. Maybe it will be better to look at that metrics instead of number of orders. Also, wrong t-tests. To calculate statistical significance, we use t-tests. But if you will Google for it, you will discover dozens of variants. And actually, this type of t-test will depend on kind of metric we have. And we haven't checked. Maybe it's a wrong metric, and it provides to us wrong results. Next point is power test not passed, which means that we could have not enough data points. We cannot look how many users were in control and treatment group. Maybe it was just 20 or 30 users, and it's totally not enough to make some conclusions. Next, what else could go wrong? It's some overlapping experiment. Especially if you work in a big company, you have different teams. And maybe some other team also launched the experiment. And accidentally they choose the same split, 80-20, and accidentally they choose the same randomization as you did. And what you observe that your changes that you see actually caused by changes from other experiment. And here you cannot be sure that there are some increase because of your changes. And you also should check for flicker users. Flicker users is those who end up at the same experiment, both in control and treatment group. So let's say in the beginning of experiment, user had Android phone, but then he switched to iPhone OS, and he ended up in treatment group. So it's the same experiment, he was in control and treatment, and before analyzing results, we should clean up such users and remove them from dataset. So you see that generating number is easy, but generating numbers you should trust is really hard. And now let's have a look how we can have results which you can trust. The main thing during experiments in data science is to think about metric. And main recommendations here is to have only one metric as a goal for your experiment. So you should and you should monitor different metrics. Because if you are looking not on some one metric but on all others, like a distribution of users across platform, across cities, you can discover some bugs really quick, very fast. If you see that all your traffic came only from one city, but you would expect from 2 or 3 cities, you will see that there are some bugs, and you can fix it as soon as possible. Why only one metric as a goal? Because your decision-making process of analyzing results will be much easier. Let's say if you think that all 3 metrics are equally important, what you will do if 2 of these metrics increase by 10%, but one metric decrease by 30%. You see that these trade-off are actually quite hard, and you will pick on your results later after experiment. Also, with many metrics, false positive rate will increase. It means that you will see that there are some difference between control treatment group, when in reality there is no difference. Under this link, there is a mathematical derivation why it increases. I will not go into details here. Also, also, speaking about metrics, proportion type is more recommended. And why? Because in most of time we are interested not how much orders user made, but we are interested in actual user behavior. Did user like make order or not? Did user click on next page or not? About metric types. There exist three types of metrics. It's continuous, proportion, and ratio. Continuous means that it contains only one numeric value. It can be gross bookings per user, as here, or it can be number of visits that user made for a website, or now like monitor value of all orders of users. And you see that in each of this example, it's some continuous numeric value. Second type of metric is a proportion type. Proportion metrics has binary indicator value, so it will be false or true. It will be 1 or 0. And why it's proportion? Because when you aggregate this across all your users, you actually receive a proportion of users who made something. So example of proportion metric is like proportion of users who complete any trips after sign up. So user made trip after sign up or not, and aggregation is a proportion of such users. And third type of metric is a ratio type. A ratio metric has two numeric values, denominator and numerator. In example of ride-hailing, for users we have a total trip request made by some customer, and also we have finished trips. And when we divide one by each other, we receive trip completion ratio. Is everything clear here for everybody? Okay. Why metric type is important? Because will depend on which like t-test and which kind of test you will use for analyzing statistical significance of your results. Let's say if you have proportional metric, you will use chi-square test. But if your metric is ratio type and your sample size is large, you will use delta method plus t-test. There are like different formulas under this, and you can just Google it. And actually, Python has all of this already implemented, so you should not know everything of this by heart. So first important part in experiments are metrics, and the second question when you should ask yourself when doing experiments is how big groups should be, or how long it would take for you to detect some difference in your experiment. So you should calculate how many users you should have in a control and treatment group. Again, formula will depend on metric type, and some of them are implemented in Python, and there exist online tools such as gpower or experimental calculator, which you can use to define a sample size for experiment. What you should have to calculate this sample size? Here is a screenshot from last online tool. First, you should have some baseline baseline value for your metric. Let's say if you have conversion as a main metric for your experiment, you should indicate here baseline conversion rate. It can be easily identified from your historical data, so you can just look what was the conversion during past 3 months. Also, you should indicate what is the minimal detectable effect you want to see in your experiment. It will mean for how big difference you're looking for in your experiment. If you are set it to 5, it will mean that if there is difference of 4% between control and treatment group after experiment ends, it will mean that they will be like the same, and you will not discover any difference. Also, there are two values here, like a statistical power or significance level, but in most of cases they are set to 80 and 5%. They relates to type 1 and type 2 errors. From my own experience, I don't change them often. So you just put all these values here, and then this online tool give you sample size that you should have for your experiment. Drawbacks which you can discover here is that if you're looking for really small minimal detectable effect, let's say for 1%, your sample size will grow much. So it will be not 1,000, it will be 5,000 users per variation. Also, if your baseline metric has lower value, So let's say if you are looking for a conversion of users from visiting your site to making purchase, and sometimes this can be 0.001. If this value is really low, your sample size also will skyrocket. So it can be like 10,000 of users sometime. And what you can do here, you can play with these values. You can choose another metric which has higher baseline value to have users really achievable for your case. Or you can play with minimal detectable effect, so you can increase it. And in real life, once you can discover that your sample size is equal to hundreds of thousands of users, and sometimes it's really not achievable. You can wait for half an year to have such sample size. And who of you would run experiments which would takes like 4 months, 5 months, half an year? Who will wait for a so long period of time? I think, yeah, nobody. Because we wanted to iterate fast. We wanted to see really quickly what will be with new changes. So one thing here, it's a multi-armed bandit-based experiments. They are our rescue for case when our sample size should be really high or for long experiments. So what are they? Let's imagine we are in a casino and we are in front of such a beautiful one-slot machine. Let's assume that some of this machine gives to us higher value than the others, but we don't know which of them. And but our goal is to gain as much more money as possible. So we try first machine, second, and third. After we discover that machine number 2 gives to us higher value, so we wanted to earn more, and we try this machine more and more to gain more money. But also there are machine number 5, 6, and so on. And we don't know, maybe they give to us even more money than machine number 2. So we explore again, and we try machine 5, 6, and we see that machine 5 actually gives higher amount of money compared to all others. So we explore different machines, and we found more optimal for us, and we exploit this knowledge and play only with the higher value machine. It's what happened in multi-armed bandit-based experiment. Compared to A/B testing, in A/B test we have 2 separate phases. We have phase of exploring or learning, so we define sample size and we run experiment. And only after experiment ends, we apply this knowledge or exploit knowledge of winner option. But in multi-armed bandit-based experiment, we combine all these phases all together. So we explore and exploit at the same time. And how it's done? So in A/B testing, we have frozen split between options during the whole period of experiment. But in multi-armed bandit-based experiment, our proportion of options change over time. And how it's changed to optimize the value which this option gives to us. So if we discover after week 1 that option A gives to us higher value, it can be higher conversion, higher number of users, then algorithm will redistribute traffic for this option A. And in this situation, we will lose less, or we will have less regret. There are different algorithms which stands behind this redistribution. But let's talk about where we can apply this multi-armed bandit-based experiment. Good thing here is that they can be used for short tests and for long tests. So for short tests, example is holidays or seasonal promotions. So if you run some experiment during Black Friday, you just run experiments during one day, but when you will later exploit this knowledge. So here you can use multi-armed bandits. For long tests, there are 2 options. First one is set it and forget it, so automation for scale. So if you have this higher number of users required for experiment, so you should run experiments for a long time, you can use multi-armed bandits, because here you can be sure that algorithm will distribute traffic in more optimal way, and you will not lose your users and your sales. Second option is targeting, and here contextual bandits are used. what they are do, they learn some rules about customers and learn what option can be applied for like different groups of users. So they learn rules and assign based experiments for each customer. And actually, contextual bandits, it's just another word for reinforcement learning algorithms. So those who worked with reinforcement learning, they can easily understand what are contextual bandits. So we talked about A/B testing, we talked about bandits, and now it's the third type of experiment. And these are experiments without control group. In real life, you can face a situation when you cannot allow your users experience different experience at the same time. So you cannot, let's say, have that users will have different algorithms applied to them at the same time. Case that we had in our boat case, we also had driver app, so application for drivers where they receive orders. And in this application, there is a map which we show to driver what are areas in the city with a higher number of orders. So we show to drivers where they should drive to get more orders. And there is an algorithm which stands behind this map. We developed algorithm number 2 for this map, and we wanted to test it. But we cannot show different algorithms for different drivers at the same time, because if we would do it, these two algorithms will influence each other, and later on we can not understand what was the effect of each algorithm. So what we came up with, we decided to do so-called interleave tests. So we ran an experiment for 2 weeks, and we split a 2-week period for 1-hour slots. And during first week, our 1 hour from 7 a.m. to 8 a.m. on Monday was our control group. Next hour from 8 to 9 was treatment group. But during next week, during second week, we swap groups with each other. So from 7 a.m. to 8 a.m. on Monday it was our treatment group, and so on. So later on, we aggregate all these results and compare what control treatment group. But doing such kind of experiments, there are a lot of potential pitfalls which can be done. Here we should be really sure that the 2 weeks are comparable with each other. So let's say if Tuesday on week 1 was some national holiday, it was day off, it cannot be compared to usual work Tuesday. So there are a lot of things which everybody should be take into account during such kind of experiment. It's only one option which can be applied here, so maybe you can come up with some other option. And now it's final notes. It's a main takeaway that I want you to remember after my presentation. As we talked, during experiments, have only one key metric for experiment. Do power calculation, so calculate how many users you should have during your experiment. Also, don't run tons of variants. Make one change, test, see what are results. Make second change, see what are results. Because if you do a lot of things simultaneously, later on you cannot distinguish what was the influence of each change. And don't overcomplicate your method. Although I talked about bandits, about interleave test, if you're think that A/B testing, traditional A/B testing can be applied in your case, just go with a simpler option. And if you see that your platform is not ready, if you don't have available tools for doing bandits, just do the simpler and the faster option which you can use. And be careful of launching things because they don't hurt. Sometimes you can see that, okay, I will introduce new machine learning models. I tune all my hyperparameters, but in real world, this model will fail. And monitor different metrics during the experiment and be ready to stop as soon as possible to prevent potential losses. And last but not least, have a data scientist or data analyst included in the whole experiment process, because those are people who know about data, about mathematics, statistics, and they can provide with results and correct interpretation of results. If you're interested what we are doing in both, we have Medium blog, so you can check it out. And also we are hiring. We are looking for like talented software engineers, talented data scientists. So check out our career page. Because both, it's not only about text, it's not only about cars. We also have electric scooters in France, in Spain, and also we are planning to work on food delivery. So, and we are expanding like in a lot of cities, countries. So we are Estonian unicorn, which are looking for new talented people as you are. Thank you for attention. Now it's time for questions.
Thank you for your talk. I didn't catch a difference between metric proportion and ratio. Could you explain it again?
Yeah, sure. In proportion metric, it can be user makes some order after sign up or not. So it can be on user level, it will be 1 or 0. But in ratio type, for user, you have two numeric values. For example, number of visits per site and number of all orders made. So for ratio type, it will be not only 1 or 0, but it will be some like bigger continuous number.
Do you have any questions? Actually, I think that it's possible to ask in Russian.
Конечно, можно и по-русски.
Thanks for your presentation. My question is about how do you deal with anomalies in your data, or probably you met the task of root causing those anomalies.
First,
please shed light.
Okay, about maybe outliers. Like, yes, it's a good example about metrics. Why proportion types are recommended? Because if you have some continuous or ratio metric, you will have some outliers. And before analyzing results, you should like remove outliers and like check it. But in proportion type, you don't have. But your question about root causes, and please explain what do you mean by this? I mean, what exactly your question about?
You don't know whether this data is anomalous or not. How you make sure that you can trust this data? Like if you are doing experiments, some of these experiments would be affected by anomalies or outliers.
So that we are looking what actually like is going on. If we are doing some experiment in a city, we are looking at what is like situation in a city. If there is some strike and like there are some block like streets on the street, actually number of orders will drop, and we are taking into account it, like comparing our like results of experiment. But I mean, we trust in our data. I mean, and we are looking at some anomalies and outliers, but what you are talking about exactly?
Okay, I think it's a bit private question.
Well, we can discuss later if you want.
Я задам вопрос по-русски. А вот это гроссбукинг, это бронирование, это как бы каунты, либо это деньги?
Это может быть и то, и другое. То есть это может быть количество ордеров, которые юзер сделал, или это может быть количество, там, суммарное монетарное значение этих поездок.
А если вот говорить о метриках, которые в деньгах выражают себя, например, количество денег, которые с каждого юзера, вот есть ли отличия в проведении тестов? Допустим, не знаю, если будет включать в себя метрика по оценке прибыли с юзера, амортизацию, там, не знаю, бензин, что-нибудь такое, как бы вот какие-то такие. Вот вы говорите про одну метрику, а какую метрику в случае, допустим, денег вы бы выбрали, и вот какие отличия могут быть?
Ну, мы чаще всего смотрим на GMV, Gross Merchandise Value, это как бы количество всех суммы цены. То есть для нас больше, мы сейчас концентрируемся на рост, и поэтому мы смотрим на сумму как бы цены, сумму всех цен этих поездок юзера. То есть мы не учитываем на данный момент бензин или какие-то другие расходы, потому что для нас главное как бы рост, а не оптимизация каких-то издержек, которые не так сильно влияют.
И то есть, есть разница вот в оптимизации такой метрики в контексте тестов, или это то же самое?
Это зависит от бизнес-проблемы. То есть, вот, например, в нашем случае мы оптимизируем как бы на рост, на growth, а если это какие-то там сокращения издержек, то это будет уже другая метрика, но здесь именно нужно учитывать как business understanding of problem.
А тогда вот еще вы говорили, что там сильно отличаться могут цифры по количеству сэмплов, которые нужны. А сколько вот получается там вы используете? Это может быть, не знаю, секретная информация, но если не секретная, какая там количество поездок вы оценить должны, чтобы понять, что действительно выросла общая сумма? 100 тысяч, не знаю.
Ну, то есть у нас очень-очень много юзеров в разных странах, и поэтому у нас никогда не бывает такой ситуации, что у нас недостаточно юзеров. То есть мы просто считаем этот sample size, и во всех случаях у нас будет достаточно кастомеров, чтобы оценить statistical significance этого теста.
Спасибо.
Спасибо за вопрос.
Здравствуйте, спасибо большое за доклад. У меня такой вопрос насчет разницы работы алгоритма. Я сейчас, возможно, произнесу неправильно. Multi-arms dealer?
Multi-armed bandits, просто bandits.
Хорошо. Принцип работы этого алгоритма на маленькой выборке и на большой. Насколько я поняла, на маленькой выборке нет каких-то априорных распределений, нет никакой априорной вероятности о том, какая опция на какой группе юзеров хорошо сработает, правильно? То есть они начинают с одной и той же пропорции. Вот я, насколько помню картинку, вот это, да, то есть серое, светло-серое и зеленое в одинаковой пропорции изначально, а их пропорции уже меняются, соответственно, по мере эксперимента, правильно? А на большой выборке вы сказали, что есть некоторая априорная информация о юзерах, которые используются. То есть вот это вот соотношение в случае большой выборки, оно не одинаковое.
То есть то, что здесь вот на первом этапе в Bandits, это какие-то априорные значения, но это как бы не зависит от большой выборки или маленькая. Если есть априорное там значение, что опция А должна давать какой-то higher value, тогда можно сразу на нее сделать там 60%, допустим, трафика.
Почему тогда на следующем слайде у вас вот пометка была для долгих тестов? Это, наверное, я неправильно поняла, это не относится к размеру выборки, наверное,
это не связано, нет.
Хорошо, спасибо тогда.
Спасибо за вопрос.
У нас еще есть время на вопросы.
Спасибо за доклад. У меня вопрос по Interlink тест. Вы его сделали с размером в час. Это реальный пример? И если да, то не слишком ли маленькое окошко для переключения? То есть у вас получается эффект от примера алгоритма с картой, он будет из одного часа перетекать в другой и, соответственно, искажать результаты.
Мы рассматривали разные варианты, то есть и час, и 2, и 3, и час это наиболее оптимальный. То есть с учетом того, что много заказов в городе, час это достаточный промежуток, чтобы оно не искажало результатов. Поэтому час это достаточно для нашего кейса.
Вот еще вопрос по поводу вот этой одной метрики, которую надо оценивать. А я правильно понимаю, что другие нужны, мы собираем разные метрики, и они нужны как бы для подстраховки. Если вот основная метрика выросла, а остальные не просели сильно, то окей, мы в продакшн. Но если либо не очень понял, как вот трейд-офф между сбором…
Нет, все равно. Главное, это одна метрика, на которой будет основана, то есть rollout нам на всех или нет. А все остальные для того, чтобы понимать, был там у нас какой-то баг, допустим, если мы видим, что мы ожидаем юзеров с десктопа, с мобильного телефона, с планшета, и мы видим, что у нас трафик только идет с мобильных устройств, то есть мы понимаем, что что-то пошло не так, мы какую-то кнопку не включили, и если мы мониторим разные метрики, это могут быть не только бизнес-метрики. Мы можем видеть, что у нас есть какие-то ошибки в том, как мы запустили этот эксперимент.
Но если меня, допустим, просели какие-то бизнес-метрики, а основная, которую я наблюдал, она все-таки выросла. Я как бы все равно в прод или я думаю еще раз? И вот.
Нет, понятное дело, что нужно думать, но и тогда изначально это, возможно, метрика, на которую ты смотришь. Вначале это будет не какая-то одна, как комбинация каких-то разных метрик. Например, если нам важно и косты, и прибыль, тогда мы смотрим, сколько мы там потратили на увеличение там, нашей прибыли. То есть мы просто комбинируем, собираем такую одну метрику, которая будет как комбинация нескольких,
Спасибо.
на основе которой оцениваем.
Could you explain what means statistical power and statistical significance? It was parameters alpha and beta when you try to calculate sample size.
So statistical power, it relates to type 2 error. So like what is in which like how you can be certain that you will not make type 2 error. So you will not distinguish like any difference when in reality it is. Statistical significance relates to type 1 error. So it's like false positive rate. So you will discover difference when in reality there is no. It's just like type 1, type 2 errors, what they are. So like this 5% mean that in 5% of cases you can make type 1 error, so you will receive false positive. And 80% of statistical power means that in like 80% you can be sure that you will not do type 2 error.
Type 2 error is false negative?
False negative, yeah, and false
Thank
positive,
you.
yeah. Thanks for question. There is question.
Есть еще?
Да.
Раз. Спасибо. Спасибо за доклад. Да, хотел такой вопрос задать. Смотрите, когда мы делаем АБ-тест, у нас есть куча пользователей. Допустим, мы какой-то пытаемся микрофичу улучшить, соответственно, ну, который будет аффектить мало пользователей. Вот, как нам правильно набрать их так, чтобы побыстрее тест сошелся? Ну, то есть понятно, что они могут по-разному с ней взаимодействовать. Мы наберем кучу пользователей, они просто ее не затестят, эту фичу.
Ну, здесь нужно, чтобы было достаточное количество юзеров. То есть если как бы мало юзеров, тогда нужно смотреть либо на какую-то другую метрику, ну, хотя нет, не кейс, наверное, здесь. Или просто нужно смотреть, что мы хотим увидеть не 1% там разницы, а если мы увидим там, смотреть на 10%, это минимум detectable эффект. То есть увеличивать вот именно этот как бы разницу между контрольной и тритмент группой, которую мы смотрим.
Хотелось бы, скажем, искусственно сместить распределение пользователей, там набрать больше активных пользователей, скажем, вот, но типа это что-то ломает нам в гипотезе. Там, мы же когда стат-тесты проводим, там есть какое-то предположение, да, на то, какое у нас вообще распределение типа значений, которые мы меряем. Вот. Если мы начнем так смещать, там можно как-то это все умно делать? Я надеюсь, я правильно, понятно выражаюсь сейчас?
Я думаю, что мы можем обсудить это после, чтобы я лучше поняла, что ты имеешь в виду.
Да.
Если вопросов больше нет, у меня есть большой сюрприз. Мне сказали, что можно подарить автору лучшего вопроса наклеечку. Выбери, пожалуйста.
Ой, это так сложно решить. Я уже не помню,
это сюрприз, да, я только что об этом узнала.
Давайте вот последний такой сложный вопрос, на который мне нужно больше подумать.
Спасибо.
Вот этому парню.
В проде автоматизированной системы, а затем разберем очень подробно два кейса с коллегами из ЦРТ про распознавание речи, какие сейчас современные подходы есть, что тащить в прод, что не тащить и как тащить, и про синтез речи. Собственно, всем привет и давайте начинать.
Приветствую, коллеги. Слышно меня нормально? Отлично. Так, скажите, кто-нибудь из вас